Good. Hi. Hi, my name is Arno. Thanks for coming for this September Bitcraze Dev meeting. And in this one, we will talk a little bit about the Crazyflie Lib and ComStack. That's two related topics, past, present, and future. We thought, revamping the library is something we've had in our mind for years now. And the idea is to talk a little bit about how we see it and how we see it evolving in the future, and hopefully in a better way. So the Crazyflie control architecture. How is everything fitting together in the Crazyflie ecosystem? We have Crazyflie and Crazyflie-like devices, like the boat, the Roadrunners, and they usually connect to a host, a PC typically, or the mobile app we've displayed here. The ecosystem usually also contains some positioning system. These positioning systems are not normally connected directly to the PC. They might be in the case of motion capture, but normally the link will look like it look in these pictures where the positioning system is connected to Crazyflie connected to the host. The host will have some knowledge and control on the positioning system usually, however, like we will see a bit later. But yeah, that's how everything fits together. And then for the lib, so what we call the lib is the piece of software in the PC that actually communicates with Crazyflie and interface Crazyflie with a programming language or program on the PC. There's a bunch of them out there. There is a Python lib, which is what we call the lib at Bitcraze normally. That is pretty much the official lib in the sense that we develop it, and each time we develop a new functionality or a new hardware, we will develop a driver for this new functionality or hardware in that lib. That's going to be part of our normal development. And this is what's beneath the Crazyflie client. And Crazyflie client and the lib is pretty much developed together as well, which for good and bad sometimes. We also have the ROS Crazyflie driver, Crazyswarm 1, Crazyswarm 2. Those implement a C++ Crazyflie lib. And it's now based, at least for Crazyswarm 2, on CPP link. So that's a C++ communication driver that's been developed by Wolfgang Hoing when he was visiting us in Sweden. So this one is hosted by us, but he's mainly been maintaining it. And the idea was to have a little bit of Bitcraze in there as well, so that we can unify a little bit how things communicate. But it's a very independent lib, and it will not have all the functionality the Crazyflie Python lib has. It will have functionality that are required for the use case of ROS and Crazyswarm. And there has been other libs made in various languages and various level of completeness. I think we have a list on the website that lists all the libs on all the language, but most of them are either special use case or they are not maintained, and so they are not up to date. There's at least one Rust lib prototype that I've made myself to play around at some point that worked quite well, but same thing's not finished. So the Python lib and the CPP lib and the ROS is actually the two main libs we have. But so talking about the Python lib and how we architecture it right now, at least, the lib exposes mainly two objects. The link, we abstract the link to the Crazyflie, but the radio link is the one that's the most used, and that's the one that puts the most constraint on everything else. For example, packet size is limited for the radio, so packet size is limited for everyone. On top of that, we have the Crazyflie object that's responsible for translating Crazyflie binary packet that we call, the protocol is called CRTP, and translate that to expose it as a Python API so that it can be used by Python program. It has some easy-to-use and expense-based functionality like log and param. So if you have ever used a Crazyflie, you have used log and param. Log to read data at regular interval, param to set data in the Crazyflie. It's very easy to add in the firmware. It's very easy to use from the lib. So this has been used and abused for a lot of functionalities in the Crazyflie because it's very easy to work with. And plus the lib also exposes a lot of custom tools and utilities. Like I say, each time we make new hardware or functionality, we add it to the lib. So that means that when we made positioning system, we added positioning system to the lib. And for example, the lighthouse positioning is containing all the position estimations of base sessions. And also, I think the saving and recall of this configuration is implemented in the lib. So that's a lot of extra things in there. At least it's easy because it's all in one, but it's also becoming pretty big. Just one word about the communication protocol because it's all very related. The CRTP is a binary protocol we've developed to communicate with Crazyflie. It has no complete flow control right now. It has a downlink flow control, so it's assumed that you can lose packet back from the Crazyflie, but doesn't have any uplink flow control. So if you send too many packets to the Crazyflie, you're going to crash it, which is obviously a problem. And there's still some case where we lose packet and we don't really know where it is, but that sounds like more like a bug. Not that crashing the Crazyflie is a feature, but that's part of the design of it at least. It is based on a port channel routing model. And what we mean by that is that there is a header in the packets that contains the ports, and the ports is supposed to be used for routing the packet to subsystems. For example, there's going to be a port for param, a port for log, a port for sending set points. The idea is to separate the firmware in submodules and to separate the lib in submodules that are pretty much independent. And that works pretty well. But we have 16 ports. So each time you add a new packet, a new functionality, you need to decide where to add it. And 16 is not a lot, so you don't want to use too many of them. So it makes it a bit hard to add new functionality. It has been designed for real-time ordering, but that has never been implemented. The idea was that lower port will have higher priority than higher port. And we have never really had the need for it. So current state and limitation of the lib. Like I said, the Python lib is a standard lib. It supports all the DEC and most of the use case. Impairs is on most like there. It is not the fastest and the most efficient lib. Python is one of the problems here. So controlling big swarms of Crazyflie using the Python lib is not ideal. ROS and the CPP lib is much better for that. It has been, Crazyflie has been designed for that. The Crazyflie interfacing code is mixed with a lot of extra libraries that we think is a little bit unfortunate. It makes the repo pretty big, and it makes everything has to fit together in some way, and it's not always so easy. And CRTP creates a lot of communications, and it's not the easiest to expand new messages. So there's a lot of byte crunching that happens in Python to build and unbuild this encode and decode these binary packets. And like I say, adding new messages is not obvious. We've tried to make that easier by adding like one of the channels, the apps channel you can use for your application if you want to communicate random data. But yeah, it's not the easiest. So what do we want to do in the future? So we're planning for an RPC-based communication with the Crazyflie. RPC stands for Remote Procedure Call here. Basically, the idea would be to expose functionality of the Crazyflie as a function call rather than a binary packets. This should reduce the lib size because we map the Crazyflie communication on a programming language, on APIs. And it will simplify a lot adding functionality because we can just add functionality by name. We don't need to choose one of these 16 ports and allocate it to a subsystem. And so it will abstract a little bit this. Log and param, we're not planning to remove them. We think they are really, really good for what they do when they are not abused. So they will be implemented on top of RPC functions. And we're planning to break high-level function utility in other libs. We don't know yet how to do that exactly, but we feel we would like to keep the Crazyflie lib focused on communicating with the Crazyflie and have other specialized lib for other use case that requires more code. And that would also help with reusability. Maybe protocols could be used in multiple libs and stuff like that, or algorithms. Packet size should not be a hard constraint anymore. That has caused a lot of design problem and a lot of problem over time. So that will be part of the communication stack, actually. The lib should support peer-to-peer communication. I don't know how much this is gonna show, but the new Crazyflie com stack will support peer-to-peer. So the idea would be that instead of having Crazyflie communicating all to the host, there's going to be a mode where Crazyflie can communicate with each other and form a network, and then the PC will be able to be part of this network and communicate with A or many Crazyflies using this peer-to-peer protocol, everyone being equal. It should help a lot with a lot decentralized experiments. And we want also to have better handling of complex use case. For example, right now, streaming images with the AI deck requires almost another lib. We have one lib for Crazyflie, one lib for the AI deck. It would be nice to unify that a little bit. And talking about the AI deck, for example, communicating with the Crazyflie through the AI deck should also be very easy. And that should be something very easy to do with a new lib. And now for the Joker. This has been something I've been pushing a little bit or thinking a little bit about, and I would like just to put it out there to see what other things about. So one idea has been to write a new lib in Rust. Rust is a system programming language, so it's very much the same level as C, but it feels much higher level when you write it. And the idea would be to make one high performance official base Crazyflie lib in Rust with binding for other languages and, for instance, Python, but we could also do binding for C++, Java, JavaScript. In my experiment, I had my Rust library work as a web client in the web browser. So that also things that are possible. The idea being to have one lib to rule them all. So no more duplicate work each time the Crazyflie firmware change. Each time we have new functionality, we add new texts. All of them would be handled by this lib, and this lib would be then used by everyone else. And I think Rust is fun, so that's also part of the interest. But yes, that is not very. That's not written in stone, but that's things we've been thinking about, and that's things we would be very happy to get some feedback about if it would cause any huge problem for anyone or anything. Kind of think it's a good idea, but just putting it out there. And yeah, thank you for listening. And if you have any questions, you're very welcome to ask them, either unmute and talk, or just write in the chat, and we will try to answer all questions.
Silence. Here we have something. Can you comment on the state of testing?
Yes, in the current libs, I'm not sure what are you talking about, unit testing?
For example, is it limited? Do you want to do more on hardware in the loop?
Oh yeah, that's a very good point. Okay. Yes, I think one of the idea with this RPC-based com stack is that we will have a API as interface with Crazyflie at the lowest level. This should simplify a lot, making things like simulation and hardware in the loop, or at least that is the intention. because the communication layer will be much easier to document and much easier to use. Yeah, more. I mean, there's going to be one level of abstraction between. In this communication, it's going to be much easier to work with. So the hope is that this is going to be made easier at least.
Good. Any more questions? Everything is crystal clear.
And no one is afraid about Rust. Good.
Yeah, well, that sounds good. Do we feel that we're done with the lib part?
Sure.
Yeah. Then I will stop the recording. So just for the people that watch this on YouTube in the future, thank you for watching and see you next time.